Another way that we can use the ideal gas equation is to modify some of the variables, moles in particular, to allow us to solve for some different quantities than are originally expressed in the ideal gas equation. For instance, we can use the ideal gas equation to help us determine the molar mass of a gas. If we think about the term N for the number of moles, and another way that we could calculate the number of moles of something, if we know the mass of a sample and we know the molar mass of that material, mass being in grams, molar mass being in grams per mole, if we divide those two, the units would work out to equal moles. So we use little m for the gram mass of the sample, capital M for the molar mass. If we substitute this little m over big M factor for N, our ideal gas equation becomes PV equals little mRT over big M. Well, if we solve for the big M, the capital M, we can determine the molar mass of the gas. And this would be useful if we have a gaseous substance of unknown composition. We have an idea of what it is. We could verify it by measuring its mass in grams, the pressure it's at, the volume it occupies, and its Kelvin temperature, and plug it into this form of the ideal gas equation. So when we rearrange, we get molar mass would be equal to the mass of the sample times the ideal gas constant times the Kelvin temperature divided by the product of the pressure times the volume. So suppose we measure the mass of a vapor, some unknown compound that we've got, and it's in a 273 milliliter gas bulb. We measure the mass of it to find that it's 3/4 of a gram. It's at a pressure of 0.959 atmospheres at 61 degrees Celsius. And so the question is, what would our molar mass be? Starting from that modified ideal gas equation, we plug in our values. Note that the Celsius temperature is expressed in Kelvin, 334 Kelvin. Also notice that our volume is converted into liters. Once again, whenever you're plugging in values into the ideal gas equation, because of that ideal gas constant and the units associated with it, you got to make sure that the pressure, the volume, the temperature, those units all match what's in the ideal gas equation, or ideal gas constant rather. And so we use 0.273 liters instead of 273 milliliters. Factoring out, atmospheres cancel, liters cancel, Kelvin cancels. The only units that are left won't factor out with one another, but if we see what they are, we have grams and inverse moles. Well, grams and inverse moles is grams per mole, which is the units for molar mass. So solving our problem, we should have 3 sig figs in our answer, and we should find a molar mass for this unknown gas of 78.6 grams per mole.